Hello, my name is Brad Goodman. I'm the Laser Resource Manager here at MakeIt Labs. And if you are watching this video, you have already been authorized on the old red Rabbit QX80 laser, and you are looking to upgrade and get authorized on the big new Epilog Fusion Pro 48 laser, which is replacing it. So if you have not already gotten authorized on the old Rabbit, or if you need a little bit more training than what this quick self-authorization course is going to do, I would implore you to look at the wiki under the Epilog training section, and there'll be some more training options in there for you. But if you are authorized on the Rabbit, you're comfortable with the Rabbit, and you are comfortable with taking kind of a quick course to give you the very basics of getting running and your self-starter, and can look up and find out other information online that you might need, this is the right place for you. So the way we're going to do it is you watch this video. There's going to be a quiz at the end of the video. Answer the questions on the quiz properly, and you get automatically authorized and turned on. Your key fob will unlock the rat. And the thing is, I will give you all the answers to the quiz right here in the video. So grab a piece of paper and a pencil, take some notes, and please don't share the answers with anybody. If I have missed any information in this video that is important to you, I will be posting this in the addendum to training on the wiki. So please pull that up, take a look at that, and have that ready. There will also be a quick start guide on the wiki as well. So if you come in and you just need a little refresh on what the procedures are and what the steps are, please check the quick guide. All right, let's get started. As with any training we do here in the lab, we're going to start with a very, very brief safety refresher. The number one rule of using the laser is that you must be, and these are the first two answers on the quiz, present and attentive. 2 words, present, attentive. You must be present and attentive when operating the laser. Present means you cannot leave the room while the laser is running. If you do need to leave the room for any minute while it's running, maybe you're doing a longer job. Job shouldn't be too long on this laser because it's much faster, so even long engraved jobs go a lot quicker. But if you do need to run out while the laser is running, you can press the pause key and that will pause the job. You can run out, do whatever, come back and resume it right in place. So you must be present when it's running, do not leave while the laser is running, and you must be attentive. Why are you attentive? You are looking for fire, risk of fire. In the event of a fire, the only appropriate measures are the fire extinguishers in the room, which will consist of this fire extinguisher right here. It is a halon one, the CO2 one below it, the big CO2 one over here by the other door. There is often a small halon one over by the computer or the laser itself. And if you don't want to use a fire extinguisher, there is a fire blanket here. As with any area in the lab, if you do use a fire extinguisher or a first aid kit, please immediately notify the resource manager or safety officer. And that's not because you're in trouble, but it's just because we need to know if fire extinguishers need to be refilled. The other rule with laser is that when you are operating the laser or any other piece of equipment, other people in the vicinity may have not taken the course, so you are responsible for the safety of others in the vicinity. And the rule that you need to enforce is eye protection. The laser and the glass on the laser should give a good barrier, but we always ask that people have a second barrier, i.e. Some pair of either regular reading glasses or safety goggles when they are operating the laser. Additionally, after using the laser, if you're taking any items from the bed and throwing them in the trash, or any debris that came off of the project, please take a minute, let it cool down, make sure it's cool before discarding it in the trash. All right, that's the end of the safety lecture. One other item that's not entirely safety related, but is sort of related, is another rule, and this will be on the quiz. Do not lean, L-E-A-N. Answer on the quiz. Do not lean on this glass, and do not place items on the glass. This can be scratched, this is fragile, this is not a work surface. Place items elsewhere, do not lean on the door. Let's talk for a second on differences and similarities between this and the Rabbit. This training is expedited because there's a lot of similarities. All the stuff on basic materials are the same. So the concept of needing measurements, needing speed, needing power, that's all the same. There's one other variable that we'll get into a little bit. The materials you can use on this laser are the same. It is a carbon dioxide CO2 laser, so wood and acrylic, a lot of organics. You can engrave things like glass or some Ceremark stuff, etc. But you can't cut those. So basically all the same rules apply as the Rabbit. Look stuff up on the wiki, or there's another online materials database. Do test cuts. The stuff with doing chlorine checks are all the same. And the general workflow is the same in that there's a lot of stuff you do on the computer to prep your artwork, and then you basically send it to the laser and hit go. So there's a control panel. The logistics of how to run the control panel are a little bit different. There's obviously the RAT over here. You have to log into the RAT as well. So a couple big differences now are, number one, this laser is 120 watts, where the old laser was 80 watts. And this one is a little bit more efficient and the alignment is better, so you're gonna see better performance. So the big thing this means for you is that you want to think about the power that you used on previous ones. You're going to need either less, or you're going to be able to cut a lot faster. So you're going to have to get used to a kind of a new baseline understanding of what speeds and powers to use on different things. Another major difference is the size of the bed. The working area is 48 inches by 36 inches. This means that you can actually do a full width sheet of plywood in here, which is important. The software is very, very different, and we're going to be getting into that in a second. Another important area is this system is air-cooled. It is not water-cooled, and that means it's a lot louder. When you turn it on, you're going to hear a lot more noise. And the important thing here with respect to safety is that when you rat in, the rat is going to turn on the exhaust system. So it can be hard to hear the exhaust system over the noise of the air cooling in there. So when you do rat in, please listen and see if you can actually hear the exhaust system kick in. It might be a little bit loud, so you might have a hard time hearing me, but the basic power on procedure is the same way. You have a big red e-stop, and like the Rabbit, you can push the e-stop to turn it off, and you can twist it to reset it. It even says twist to reset on here. So again, if you go to power it on and you don't hear anything, it's a good chance that there's the e-stop set. And there's also the main key switch should be the normal way to turn things on and off. One of the big differences between this machine and the Rabbit is that this machine, it's a lot more complex in terms of the UI, so there's a boot up process, so it maybe takes a minute or two to come all the way on. So a basic procedure would be turning the laser on, and again, then you can rat in, and when you rat in, I want you to listen. I'll do these independently right now, but listen for the exhaust to turn on. So if I rat in right now, you'll hear the exhaust kick in. That's the exhaust noise. Now, as I said, the laser is really loud, so I'm going to turn this on right now. And so at first, you're not going to see anything. You're going to hear a little bit of a fan, and then you're going to hear a pump turn on. Always listen for the pump, and then you'll hear the air coolers turn on. So much more noise, and then this is what I mean by over this noise. When you rat in, you want to listen for the exhaust. So just make sure all those are actually running. So the air pump, the cooler, and the exhaust when you finally rat in. After doing this for maybe a minute, you'll see the display come on. White display, and after which you're up and running and ready to go. It's also noteworthy that the rat, again, like it does on the Rabbit, it only affects the actual firing of the real laser itself. So if you are not ratted in and you go to use the laser, it'll look like it's working, but it won't actually cut anything. So if it's not cutting, again, it's either two things. It's either the door's not shut or you're not ratted in. The same rules also apply for rat. When you rat in, it's going to give you about 10 minutes of idle time. And after the 10 minutes, if you don't actually fire the laser, it will actually badge you out. And when you're badged out, again, you go to use something and the laser won't fire. So it will give you a 1-minute warning before it badges you out, and you can use the blue item to reset that idle timer. Like that, reset yourself and give yourself another 10 minutes. But if you're actually firing the laser or using it, then it won't idle. It'll actually count that as use time. It will not badge you out while you're using it. So one big change with this laser from the other is that the software that runs this laser is not a full CAD system like Laser Cut was. It is a simple print driver. And what that basically means is it wants you to use whatever software that you're comfortable doing your design in, whether that's a CAD-based system for vector cutting or an artwork-based system for vectors like Inkscape or CorelDRAW or Illustrator, or you're doing photo engraving and you use either GIMP or you use something like Photoshop. Use whatever program you want on the computer, and then you hit Control P, you print that, but you're printing right into the Epilog software. So that's a difference in the flow there. What this also means, it's really neat, is that if you have a laptop that you have your software, your setup on, and you want to work right in that, you can go right into Epilog's software site and download that. So right in the Epilog page on our wiki, there is a software download link, and that'll take you right to the software that you can download and install on your computer. And when you do so, it is an Epilog Fusion Pro 48 that you want to set up. So if you do set this up on your own PC, you say that the system is a Fusion Pro. It is a Pro 48 here. It's going to ask you for which power setting it is for the CO2. You're going to say 120 watts. When it says select which fiber is installed, you're going to say not installed. The IP address you can get right off of the wiki. We will put that on there, and it's a constant address which shouldn't change. You should be okay with that. There's also a way that you can get that off the laser itself. But after putting that information in there, you should hit next, and your software will be configured so you can actually bring it in and use it right in the lab. It's also important to note that you have to be on the MakeIt members network in order to actually reach the laser. You can't reach it from the guest network. Whether you're using the PC laser in the lab or you've installed the software on your own, it's going to install two components. One's called Epilog Job Manager, and I want you to ignore that for now. But the important one is the Epilog Dashboard. We're going to see how that works in a second. But like I said before, the important point is that you're using whatever software that you want to use to do your design, and you're using that to print it right to the software, and I'll show you how that works. So on the PC, on the laser, in the lab, I've installed a few different packages right now. One is Inkscape, which is a fantastic open source vector program. The other one is Adobe Illustrator, which is sort of the premier paid vector illustrator, and a couple CAD systems. One is QCAD, another is LibreCAD, and LibreCAD has been a great one that's been around for a long time. We used on the Rabbit to basically import in OpenDXFs. And the idea is, there's also GIMP, which I put on for photo editing, and we may put others as well. But the idea is no matter what software you're using, you should be able to do the design in that software and send it right to the Epilog software. So right now I work in Inkscape a lot, so I'm going to pull up Inkscape and I'm going to draw a simple thing, which is a star. I don't know if you can see it because the line is a little bit faint in this picture. I will increase the stroke size a little bit to maybe darken it. So the idea is that, and I'm going to make another copy of this. So this one I made with a thin outline stroke, and the other one I'm going to make in red, and I'm going to not put a stroke around it. I'm only going to put a body fill on it. So the important thing to note in whatever software that you're using is the Epilog software will interpret thin strokes as vector cuts and any larger bodies or bitmaps as raster engraves. So if I now just take this design which I have created and I do a regular Control P to print, as you may be able to see, I get a standard print window that is now open, and the print window, the default on the Laser PC is Epilog Engraver. And if I say print here, it now automatically opens the Epilog dashboard, and you can see right in here is the item that I sent over. And because this was thin, the way that it works is, if I look over on the right, so this right here is our processes tab, and this describes the stuff that we sent over and how we're going to work with it. You can see my job right here, and it says everything, and it says process type engrave, vector off. So these are the important things right here. This is a function of how it interpreted what it pulled in. So in this particular thing that I pulled in, there was this black thin outline and this red filled area or body. So I could tell it that I want to vector cut it, and if I say vector cut it, it is going to interpret only those pieces which are thin lines. And we'll get into the definition of a thin line in a few minutes, but the important part to think about it is that it should be less than like maybe 1/10 of an inch. So any features which are thin, like less than 1/10 of an inch, it will interpret as a vector cut line. And raster engrave, I can raster engrave anything. In this place, it's two things. Now, what if you were to say, well, wait a minute, I want to engrave the red piece and vector cut the black piece? Well, there's a couple options. I can take this one piece of artwork and I can split it by color or split it by hairline. And if I split it by color, it should do what you think. It should separate the black elements and the red elements. And when I do, I now have a black and a red. And since it came up and detected this job as an engrave, you'll see that they both say CO2 engrave. So if I click on this, it's engrave, and that's good. So I can get detail on any of these. I can reorder if I want to change the order, like engrave and cut, or cut and engrave. But if I click on this, the point here is I don't want this to be a engrave, I want this to be a vector. So I have my nice outline vector, and I have my, my red engrave. Long story short, I can set speed and power here. And these two are for, there is a library. And like with any library, it is up to, you know, whoever put the stuff in the library, if it's good or not. These are references only. But so what speed and power settings do I use for this vector? I don't know, but if I go into the library will give me a bunch of options that I can pick through. And this is what, 1/8 inch 3mm wood. I can click that, and when I do, it gave me some advisories. And this advisory is saying 100% power, 20% speed, which is probably worth a good starting point. I might even go, depending, you know, 50% speed or something. But again, you're used to the Rabbit. The Rabbit is a lower power system, so all the speed and powers are going to be different. Another thing that's important to mention is that the speed here is a percentage. It's not like an explicit millimeters per second like it was in the Rabbit. Again, another important thing here to know is these are advisories. So you're going to have to play with stuff. You're going to have to see what works. You're going to have to do some test cuts. Another important thing to note, obviously, is this thing now gives us this other variable, which is called frequency. And the best thing that we have been taught as a frequency is this is more of a function of the material. And you can think of it a little bit as harder materials have lower frequencies, softer materials have higher frequencies. So we've been told, for example, wood is about 20% frequency. If I was doing something like a rubber gasket, that might be a much higher frequency. Let's see what something like an acrylic would be. I have no idea. So if I were to do, oh sorry, those were engraved settings, but at the top there are different settings for vectors and for engraved. So if I'm doing an acrylic vector, what would that look like? I can double click on that. So this is saying, and again, this is advisory only, but saying that acrylic is going to be about 25% too. So frequency is not extremely important in terms of how it's going to cut, but I think it has a big effect on particularly edge quality. So for example, this is a piece of acrylic that was cut on the Rabbit. This is a piece of acrylic that was cut on the Fusion. So you can see it's a nice glass clear edge where it's very hazy on the rabbit. And some of this might be difference in materials, but a lot of this has to do with the cut quality and the frequency involved. So frequency can help you get cut clarity. Before we continue, I just want to stop and re-emphasize what I just said so it's really clear. And again, I would highly implore you to download the Epilog software and to pull up your favorite program and to try this yourself. But if you describe in your artwork a thin geometry, and you can think of a thin geometry as something like 1/10 of an inch or maybe a millimeter or maybe a single pixel wide, if you give it a thin geometry, the Epilog software will be able to interpret that as a vector. And if it's not, if it's a bitmap, if it's a thicker area, if it's a thicker line, if it's a filled region, it will only be able to vector engrave that. So if you go into the software and I take this artwork, for example, this is a giant filled polygon, and I go print, and I'm printing to Epilog, and it pulls up inside the Epilog software, and now I go in and I say, hey, I want to actually raster this. So I go from engrave and change it over to vector. Everything disappears now. Why did it disappear? Well, it disappeared because this geometry, which I sent it, again, it was a big filled area. It was not a hairline or not a small line. So again, if I take this and I'm going to I'm going to outline this, that's a little big, but if I give it a reasonably small outline path and then I print that, now I can say vector, and it's going to understand that this is the vector components, and I can set power and speed there, or engrave, and it's going to interpret the whole thing. So this whole thing would be engraved, both colors inclusive. And if I really wanted to split it out again into different things, I could split by color. All right, here's one of the little wacky process thing. Suppose I have an artwork like this, and then I take one like this. We talked before about splitting things by colors, but let's just say here, hypothetically, I have a few different shapes, and let's say they were all the same color, and I go to take this, I Control P, I print it to my Epilog engraver, and as expected, it pulls it in as such, and I have all these things here, and that's one. Now these things here, they're not called layer, they're called processes. But like I said here, I have everything under one process. So what I can do is over here, I can take this artwork right here, I can select it, and I can use this ungroup. And when I ungroup it, all it really does is it allows me to then go and to move these things around individually. Now it's worth noting here that notice how when I hover the cursor around, I get different things. Like this is the hand allows me to move this center dot, which is sort of a positioning thing we'll talk about in a bit. The arrows allow me to actually move the object, or this one will obviously let me resize it. This one will let me rotate it. But the point here for this is I now have 3 different objects that I can independently move, although we're still talking about the same process. So what I can do here, if I wanted to do things like have a different cut quality or something, or I wanted to raster one, is I can add a new process to this list. And the one that I have, when I did that, the one that I had selected wound up being in this new process. So this would allow me to do things like, say I want to vector cut this but rastered this, or I want to use different speed and power on this than in this. And I also do have the ability to do something like take one of these, right click on it, and say I want to move this to one of, I have 2 processes, everything in selection, because they were just named by default. But so I can move one from one to the other, etc. by doing that. While we're here, let's talk about some other things under these different processes. One is Bezier's. I don't know exactly what this does, quite frankly, but vector sorting. I have none, inside out, or optimize. This is basically saying how do you want it to cut. For example, if you wanted to cut interior ones and then exterior ones, because like you wanted to control the drop order, that's how you do vector sorting. None, I don't know what that is versus optimize specifically. Cycles is if you want to do multi-pass automatically. Offset allows you to automatically apply a kerf to it. Now those are the settings for vector. Now let's say hypothetically I wanted to engrave this up here, which they're only thin lines, but I could engrave thin lines if I wanted to. I have a few different engraving options that are different. Obviously speed, power, frequency are all the same. Resolution is another engrave thing. I can do a finer grain versus coarser. Dithering, we talked before, I don't know if you've seen the video, these are all different dithering methods. I would just implore you to try these out and to see what kind of results they give. It deals with grayscale or black and white to dots and darkness controls, so you can try the different dithering methods, and we'll probably print out some demos of that. Unidirectional, again, are you engraving left to right or both directions from that? Precision sync we'll get into a little bit, and again, offset and cycles are the same as it was. So direction is, are you going top to bottom or bottom to top in your engrave? And what we have been advised is that you always should change the direction and make the direction engraves go bottom to top. The reason being is that there's two exhausts on this system. One pulls it down through the honeycomb, and the other one pulls it out through the back. So as material burns off of your piece and it deposits down, the stuff from here is going to pull off this way. So it's going to leave this area clearer. So if you're going from back to front, you're going to have it not over lasering debris that has come off as much as if you did top down to bottom. So those are the basics, and when you're done and you have your processes done like you want them to do, basically all you're going to do is you're going to hit this print button. It's going to send that job to the laser. But I've been covering this as is because I want to do it with the lasers off as much as I can. So again, I would implore you to get the software, to download it, to try all this stuff, to make sure that you have the ability to take your artwork from your program, to print it into here, and to be able to separate it out as vectors and rasters with the settings that you want. And if you get that, that's like 99% of figuring it out. A few other very mechanical GUI based things. One is obviously if I hit these are view options up here, and if I go view to table, I get a representation of the entire 48-inch by 36-inch bed. If I say to fit, it's going to zoom in on my artwork that I have. And in terms of navigation, I can use the mouse wheel to zoom in and out to where the cursor is. I can push the mouse wheel button and pan around the table like this. And I can use, obviously, this arrow mode right here to select things. And we talked before about dragging, and we'll get into this center dot in a second. The other thing I want to briefly mention are the honeycombs. There are two of them on this laser, and they're used for different things. Whatever honeycombs we are not using are stored over to the right of the laser, so that only the ones that we're actually using are on the laser bed. There's actually two physical ones on the laser, so you can actually put two in at once, or you can split them. So this one right here is the traditional honeycomb, and it is used for vector cutting because it raises the material off and allows materials to drop through the slats after you have cut them out. It is actually very light to remove these. They're pretty thin aluminum, so be careful with them, although they are very easy to remove. When you use the honeycomb requires these bars to be in here for support. So when you are not using the honeycomb, remove these. The second one is called an engraving plate. And the engraving plates are actually marked with front left and front right designations. So make sure you're putting them in the right orientation and in the right spot. But when you put these in, if I have one next to the other, notice because I removed the bars and there's still the bars in here under this honeycomb, these are flush. And so it's important that you get the bars with the honeycomb, but not with the engraving plate, so that things are at the right height. The engraving plate is typically used for engraving, hence the name, but particularly for thin materials like paper, cardboard, etc. It has two good properties of it. One is that material isn't going to fall through these holes because they're very small and even there's some blockage in here. The other thing is that since the holes are very small, they'll tend to suck down and hold the materials, i.e. if you had thin paper that could blow around with an exhaust fan or something, an engraving plate is going to tend to suck that down to the table better. Obviously, because the honeycomb is much more porous than the engraving plate, if you're not getting enough suction with the engraving plate, you should put 2 engraving plates in because it's going to have a lot more draft through here. It's typically important not to cut with the engraving plate, number one, because you could mar the engraving plate, which isn't too horrible. But the bigger problem is that you're not going to get really any exhaust through these holes in the engraving plate like you need if you're actually cutting wood and need to pull the exhaust away. So honeycomb for cutting vector, engraving plate without the bars for engraving. That's not to say, of course, that if you are doing an engrave on something where it's not as critical that you get that suction down to the bed, you can certainly use it on the honeycomb. So I would say a standard operating procedure should be, in general, leave the honeycomb in here and only use the engraving plates when and if you need to. And if you're putting the engraving plates in, please change it back to the honeycomb after doing so. And of course, remember to put the bars back in when done. For the placement of the honeycomb, you want to have it so the aluminum is down, not up where it's going to get hit by the laser inside the focus range. So we're going to try to mark them as such with the wrong side, but make sure that they are placed in this orientation, not this orientation. Another cool thing, which you will be less tormented with and with the rabbit, is this side panel opens very quickly just by grabbing it and pulling it. Needless to say, if you do, the interlock will not close and the laser won't fire, but this is a really easy way to getting at the plates to get in and out. All right, enough chit chat. Let's fire up this bad boy and get to business. So again, in theory, we can fire these things up in any order. I'm going to do the rat first just so we can hear and verify that the exhaust fan is on. Exhaust is on, and now I'm just going to make sure that this is in fact reset properly, and then I'm going to turn the key to the on position. When I do so immediately, I'm not going to see anything. First, the lights are going to come on. I'm going to hear a little fan, then I'm going to hear the pump come on, and then I'm going to hear a little bit more noise when the coolers come on, and in a second we're going to see this light come on. That was maybe like 30 or 60 seconds for the light to come on. Then this guy's going to come up, and after it does, then the laser is going to be in business. There we go. It's going to go through a little homing and a re-zeroing procedure, so keep your hands clear when this thing first powers on. And it's going to go back. It will move the table, so keep your fingers out of any pinch points in the table. And then when doing so, we're going to see it's going to come up in idle speed. So I'll try to talk loud because the machine is on and it's noisy, but let's go through this panel right now. And I'll start with the most important stuff first, and then we'll go down to least important. This button right here is the jog setting. If I push this right here, the jog menu comes on. And when I'm in the jog menu, I can use this joystick right here to move the head around. Up, down, left, and right. I can lock the axes too, which is a little bit unimportant. I can use this for fine nudge control. I can send a center point and move to there. Centering point we'll get into in a minute. Autofocus is obviously important. So again, very much like the rabbit, we have a autofocus button right here. And if this button comes down and hits the material, that's how it establishes autofocus. Obviously, like the rabbit, make sure your material is under the button when it's autofocusing. But autofocus works very much the same way as the rabbit does. Like I can press that autofocus button,
And when doing so, we will see it do the expected. There we go, autofocus. While we're talking about autofocus, there's another way you could do it. So there is a explicit focus menu, and this will always show you the actual laser position right now. You can nudge the table up and down, and I can also use the joystick to move the table up and down. There is a manual focus option, and the manual focus option is this thing right here, which you can fold down, and you can see that it is not, engaged. And when that's in place, I can then use that joystick button, and I can establish a manual focus like that. So that's another option for focus. When you're done, you can come out of this menu like that. Another important, so we talked about the jog, the focus. This is a red dot. It's kind of poorly marked. Does it look like it's going to fire the laser, but it won't. When I push that, that is when the red dot comes on. So if I push it again, dot off. So you will only see the red marking dot. I don't want to call it mark because that confuses people on the MOPA. But that red laser will only come on when that button is pushed in. This one right here, we're not going to push it right now. Well, let's see what happens if I do. Nothing because there's no job loaded in here. That is the same as the test button on the Rabbit, and that will draw a bounding box, and it will keep drawing a bounding box when I press it. Only other button down here is this one, which both returns to home position, and it does so very quickly. But that's also the button that we use to stop a job if you want to actually stop one. So moving up the panel here, this button right now is the settings. Please don't go into it and change anything because you're going to mess things up for other users. The one exception might be is if you do press that button, it will give you the network IP address of the laser. And this is important if you're going to bring your own computer in and you want to set it up to print directly from your computer. You can use that IP address and plug that in, or you can look on the wiki and we'll have that IP address in there. One of the most kind of default important ones right here is this what we call the hamburger menu. And the hamburger menu, if I take a job in the software right now and I say print, what it does is it actually takes that job and it sends it to the hamburger menu. And once it's up there and it's selected, if I just push this button, it will run that job. So you can have a couple jobs in here, you can select them, you can hit delete to delete them, and we ask that when you're done with the laser and you have a bunch of jobs in there, please delete anything for the next user. One of the amazing parts of this laser is we have two cameras here for positioning. Now these cameras only work properly when the door is closed because this is what it looks like when the door is open. But if I close this door, now the cameras can have a view of the bed. So let's blast a job. I've done this guy right here. I have made my stroke very thin, and if you do a thin enough stroke, it'll automatically recognize it as a vector. And then I have some other art that's thicker. And if I simply do, again, my Control-P, print to Epilog engraver, and when it comes right up, so I have my table, the camera view, which has the wood in here that I have sitting in here. And it also has a page. So if you adjust the page size, it'll kind of crop it down here. And if it's too small, because it won't allow you to print inside this pink area, you can take these lines and you can move them. And I don't really know why it does that, but it does that based on the page size that you printed with. So I would advise that you send over a 48-inch by 36-inch page size, but if you don't, you can always drag it. So as long as you don't have anything that's pink. Now again, I can view to table like I am now, or I can also view to fit if I can't find where that artwork is. But again, looking at the table, I'm in this picker tool, so as long as my cursor is giving me these arrows, that means I can drag this. I can put it right down into the wood. I can even zoom in with the mouse wheel and determine exactly where I want this guy to sit. I can pan, I can say, yep, that I'm going to nudge it right in just like that. That looks good. And when it's done like that, now I can look over here. Now notice, so autofocus is off, and the reason that it's off is because we already manually did that focus. If we turned autofocus on, it would actually attempt to do an autofocus as a part of that. So there's a couple different mechanisms to that. I won't get into that in this video, but let's just say it's off right now. So it interpreted, again, my hairlines as vector and my red as an engrave. If I want, I can go in and adjust those, or I could pull up a material library and I could say, hey, I want to do engrave some wood. Sure, why not? That. Okay, I'm going to use that. And then, like I said, direction, you typically want to go bottom up, which is not the default. But now if I go into my vector settings, again, for like wood, I think we've been typically doing like power 100, speed 50, frequency about 20 for wood, but check your settings. And that's really all I need to do. So now I have that all set up like that. All I need to do is hit print. And when I hit print, and I look over here, so it always puts your newest thing and it highlights it and puts it right up at the top of that hamburger menu right there. And so when that's selected, all I have to do is hit print. And when I do, that's the engrave. You can see it's a wee bit faster than the rabbit. That is the cut. That's pretty damn quick. Maybe even high power. And then we're done. That was it. You also notice, so I did 100% power, so that was as much power as I could possibly throw at it. And I did a, enough speed to get through it. And you notice that when you do so, I don't even really get any charring on that. It's a little bit dependent on the material, but almost no char with that. By the way, and this will be on the quiz, this was supposed to be Rick, R-I-C-K. Yes, it was. So that's on the quiz, write that down. I just want to show you one little common mistake. If I do a Control P here and I send this guy over to the software, now again, we talked before about this pink area as being the no print area and this is being the okay area. If I look at this right now, it's telling me this is going to take 21 seconds to engrave and 6 seconds to run. If I were to take this right now and move it into the pink area, it now is telling me 0 seconds to engrave, 0 seconds to run. Why is that? Well, because it's in the no print area and there's nothing in the print area. And what does this mean? This means if I actually print it and I send it over to the machine, and now I notice that the time on this is 0, 0. And if I go to print this, it didn't do anything. So why didn't it do anything? Again, make sure that you're not in the pink no print area.
All right, another advanced flow. Let's say I wanted to make a bunch of these things, and I can print this. It's a small line, so I'm going to again print it into the software. And when I do, it comes up right, and it's right in there. But let's say I want to make a bunch of them, and I don't know exactly where I'm going to be placing them, but I want to move it. I can go advanced, and instead of the normal thing where I'm use camera positioning, we're doing what's called center point positioning, which I'm going to say, this is sort of like the alignment on the rabbit. I'm going to say center positioning on this. And when I do, I now have this center point right here associated with this. And when I send this job over to the laser, because it is in this center point mode, now it doesn't have to literally be center, but it could be center, it could be left center, which would do that. Again, this is like the orientation on the rabbit. But when we are in this, what is called centering point mode, and we send this over to the laser.
So notice that now when I have this job up here that I just printed, it shows up with this center point icon in here. And that means this job is going to print relative to center point. And that also means that I can go now into, for example, the jog menu. I can move the laser wherever I want it. I can turn that red dot on for a little bit more precision. And when I have what I want to be the center point, in the jog menu, I can hit this center point button. And that center point button will describe that point that I'm at right now as the center point. And which means that when I hit this test button over here, sorry, I have to be in the document menu. When I have the document selected and I hit the test button right there, it's going to show me that bounding box. So I can shut this guy off. I can print this. Can't quite see with the reflection of the camera. It did it there right at that center point. Now if I want, I can go back into jog, move it somewhere else, hit that center point, again go into the hamburger menu, hit the test button, see that it's going to go there, cancel out that test, hit print again, bad camera view because it was so quick, but it just did that again. And at any time, like I said, I can stop by hitting this in the middle. If I do it with the door open, it'll run, but it's not going to fire the laser. I can pause during the middle of the job. I can use this to cancel a job or send it back if I want to. I shut everything down already just to be quiet, but obviously when we're all done, what we want to do is we can leave this in the off position. We want to either rad out, it'll time us out, or we can hit the yellow button as always to shut off the exhaust and to rad out. And when we do, everything should be nice and quiet. Now, a couple of formal shutdown procedures. Number one is we don't have a big catch basin on this like we did with the Rabbit. So when we are done, we want to clean out anything that we've done. So this door, like I said, just pops open with your hand. We have these latches right here, and when you pop these up, these trays come out like this. So if there's any debris in here, again, make sure that it's cooled off and there's nothing hot. But there's 3 bins. Make sure that you've emptied them out. You can either pull them out and dump them in the bucket, or you can use the vacuum because the hose is long enough to clean those out. The other thing to remember is if you were using the engraving plates, please remove the engraving plates. Please put the bars back underneath and put the honeycomb back in there, and just maybe give a quick wipe down to anything that was messed up during what you were using. I think I made a previous comment about deleting stuff, but I think when you power the laser off and turn it back on, I think it might delete anything that was there, so I don't know that you need to do that. But that's the basic shutdown procedure. So again, please make sure those trays are emptied and put back and locked into place when you're done with the machine. And the only last thing I can say again is check and this is the last question on the quiz, check the wiki, W-I-K-I, for both the quick start reference, which can be amended over time, for the IP address of the machine, which you'll need if you're installing software on your own system, and of course the addendum on training if there's anything that I missed or screwed up in this video. Other than that, so go online again, take the quiz, answer those questions that I laid here correctly. You should immediately be authorized on it. If you have any questions, generally post in Slack and let us know how you make out any cool things you do. Thanks for watching.